Welcome to Be the Programmer, where we learn real-world skills and build real-world projects to help you become the programmer that stands out. Before we get started, the courses in the description below is going to help you take what we've learned here today, practice it by building real-world projects. So be sure to check it out and let's get started. Welcome. So 10 things about useEffects that separates juniors from seniors. Let's get started. Before we start, we're going to have to start with a quick test. Remember to keep your answers in the comment section below, and I'll be sure to check it out. Question number 1. Why does your useEffect run twice on mount in development? Question number 2. If you fetch in useEffect and the user navigates away, what happens to the response? Question number 3. When should you not use useEffects, even though it would work? So remember to leave your answers in the comment section. Okay, number 1. useEffects is for synchronizing with the outside world. So let's take the code on the left, for example. This is not what useEffects is for. It's not for running code when X happens. It's not a lifecycle method, not component did mount. Instead, what it actually is, it's, for example, let's take this useEffect function. You can see we use it to connect to the external system. In this case, we're connecting to a chat and disconnecting from a sub. So you see, disconnect when synced state changes. And in this case, what's changed is the room ID. Okay, an effect synchronizes a piece of React state with something outside of React. So by outside of React, I mean the DOM, the browser APIs, network connections, third-party widgets, animations, subscriptions. If your effect only touches React state, it's probably not an effect at all. So effects are not callbacks, they run because something needs syncing. Each render creates a new effect with the render state baked in. The cleanup function reverses what the effect did. Okay, and by cleanup function, remember, it's when we return a function, like in this case. And remember, each renders has its own effects baked in, just like we said here. Okay, number 2, 90% of your useEffects shouldn't exist. Let's look at the code on the left. Effect for derived state, storing what you can compute. So in this case, we have a state for the first name, and then we have a state for the last name. And then we have another state for the full name. Then we say if the first or the last name changes, we want to update the full name with the first and the last name. So you see, this causes an extra render and is bug prone. So with this, we're going to have 2 renders and then a possible flicker. Instead, what is the correct way to handle this? Let's take a look at the code on the right. So during render, rather than an effect, we can just compute the full name. So we still have the first name in the state and then the last name. And then during the render, we can just compute the full name by joining them together. So as you see, this is always going to be in sync and is going to be just one render with 0 effects. Okay. Other you don't need effect cases are resetting states when prop changes. Instead, use key. Updating states from event handlers, just do it inline. Fetching data, instead use a framework, server components, or Tanstack query. If your effect's only job is to update a React state from other React states, it shouldn't exist, like this case. Okay, number 3. The dependency array is not when to run. Let's take a look. What dev thinks this means? Run this effect when room ID changes, like in this case, right? What it actually means is resync the effect if anything in the list changed since the last render. So again, this dependency array, it's not run this effect when the room ID changes. Instead, it is resync the effect if anything in the list changed since the last render, in this case, the room ID. Okay, so then we disconnect the old room and we connect the new room. So this is the cleanup. So we disconnect first and then we connect again. So you see dependencies are the values your effect to read. In this case, we have the room ID, all of them, no exceptions. So the linked rule, in this case, React hooks, exhaustive depths, isn't being annoying. It's preventing stale closures. Don't suppress it. Either include the dependency or restructure so that you don't need to. So remember, empty array, this effect doesn't sync with anything reactive. No array, this effect is going to run after every render. This is very rare. And when we have dependencies, like in this case, we resync when dependencies change. This is the most common case. Okay. Number 4, every setup needs a teardown. So when we don't have any cleanup, this could result to some leaks. So for example, let's look at the case of adding event listeners. So this useEffect, it first sets up a handler, then we'll add a event listener for resize, right? And then we don't return anything, so the listener stays even after the component unmounts or re-renders. So this can result in memory leaks. As you can see, we could have multiple handlers stacking on top each other. Instead, let's take this approach. So we're going to clean up, we're going to clean up which undoes the setup. This is called symmetrical effect. As you can see, this effect, which is the same thing, we set up the handler, we add the event listener, but what is different is we then return a cleanup function. So remember, whatever we return from a useEffect is going to be the cleanup, which is going to run before the component unmounts. In this case, we're saying remove the event listener that we added, in this case, the resize. So you can see this is going to be a clean teardown and it's going to result in no leaks. So what is the rule of thumb? For every add event listener, set interval, connect, subscribe, observe, you need a matching remove, clear, disconnect, or unsubscribe cleanup. The cleanup also runs before the next effect, so you never stack subscriptions. Okay. Number 5, strict mode runs your effect twice, and this is done on purpose. So what's the flow like? In development, strict mode does this. We mount the components, run the useEffect, run cleanup, run effect again. This is React asking, does your cleanup undo your setup? If your effect breaks when run twice, it would also break when navigating away and back, or with React 19's activity of screen features. So if you can't survive 2 runs in development, you can't survive real users either. Don't disable strict mode to fix the double runs. The double runs isn't a bug. Your effects not being resilient is the bug. So the common fix is add your cleanup. Use a bot controller for fetches. Use refs to guard one-time actions. So a correct effect is idempotent. Running it n times produces the same result as running it once. Okay. Number 6, fetching in useEffect causes race conditions. So let's take the code on the left. This is just a naive fetch, races. So the wrong data appears. Why? Because as you can see, we're fetching from this API, then converting to JSON, then we're calling a setter function here. Okay, so the user click fast. If the user clicks ID 123, you can see the response 1 arrives last. So the UI could show the user 1 instead of showing user 3. So if the user, again, I'll just go through this. If the user clicks ID for the users 1, 2, 3, and for some reason, the first one, right, that the user clicked comes last, we could end up with the UI showing the user the data for the user 1 instead of user 3. So as you can see, the stale response wins and the UI is going to be wrong. Instead, what should we do? We should cancel stale requests. Okay, so what does that look like? So in this useEffect, we're going to first set up our abort controller. Then we're going to call the fetch API again. Then we're going to pass in the object signal, which will have the control.signal. Then we'll convert it to JSON. We do our setter, and then we set up our catch. Then this is the cleanup. We're going to return control.abort. So as you can see, in this case, the latest is always going to win, and the old requests are going to be aborted. Better still, don't fetch in useEffect at all. Use a framework like Next.js using the Next server components. Again, be sure to check out our Next.js course where we go in deep details about this. You can also use Stack query or React 19 use hook with suspense. They all handle race conditions very well, caching, retries, and loading states for you. Number 7, the stale closure trap. In this case, we can say in the useEffect, we have a setter function for the set count, which uses the current value of count in this render, and this is going to result to a stale value. Instead, what we want to use, just like we saw in our other video of the use states, we always want to use the function updater. This is because we're going to use the current value in the latest render. So empty dependencies freeze every variable inside the effect at the first render value. So as you can see, at the first render, count is going to be 0 and is going to remain 0. So if your useEffect reads states and you used an empty array, like we did in this case, the state is captured forever. Two clean fixes. Use the functional updater for the set state, or include the value in the dependency array, which restarts the effect. For set state, call functional updater is almost always right. For other values, include in dependencies or use useRef to have the latest read. The linked rule will tell you this, and listen to it. So depending on the IDE you're using, you could get an error message telling you to include the dependencies in the array. Number 8, object function dependencies run every time. So let's take an example. On the left, you can see we have an object options. Okay, so in the useEffect, when then using these options we're adding it to the dependency array, and this is going to result in a problem because with every render, the options is going to have a new reference, which will cause the component to update again, resulting in an infinite loop. So as you can see, new object equals to new reference equals to infinite loop. Instead, we want to depend on values, not objects. So in this case, instead of having the options, which was an object, which held the headers, we just passed the object inside the useEffect, right? So as you can see on the left, the options was outside the useEffect. So this will cause it to have a new reference on every render. So instead of that, we just put the object directly inside the useEffect. So this is going to cause the primitives to compare cleanly. So the patterns, declare objects functions inside the useEffect so they aren't dependencies. Use useMemo or use callback if they must be outside, or extract to primitive dependencies. With React compiler in 2026, this gets handled for you, but until you ship the compiler, this rule bites. Number 9, don't run code in response to events. Just run it in the handler. So as you can see the example on the left, spooky action at a distance. As you can see in the useEffect, we say if submitted, we want to show a toast, and we want to track this analytics for save, right? So this logic far from the action. This logic is far from the action, right? It's hard to read and it's going to be hard to debug. Instead, let's set up a function. called handle summit, where after save, we then show the toast and we track the analytics. So this is all in one place. It's obvious, no wasted states and no effects. Self-documenting, one source of action. So what is the rule here? If something happens because the user did something, put it in an event handler. Effects are for syncing with the outside world, not for changing reactions to user actions. State doesn't need to trigger anything. Okay, the last one, in modern React, useEffect is becoming a last resort. So let's look at data fetching. Use server components or React use function. Server component fetch on the server, use reads promises in client components with suspense. Both eliminate the use of effects. As you can see an example here, you can also be sure to take our Next.js course where we build a real world project and go into this in more details. The next one, form submissions. You can use server actions or use action states. No more effect for handling pending, success, or error states. Use action states gives you all three for free. And we can see an example down below where we can just destructure the different states or statuses. Then the next one, when you do need it, truly external systems, DOM measurements, third-party widgets, analytics, WebSockets, animations, and etc. These cases still need useEffects. So you can see an example again down below. Okay, so the useEffect cheat sheet. This is the mental model, what it actually is. useEffect synchronizes React state with the outside world. If your effect only touches React state, you don't need it. Dependencies are the values your effects read, list all of them. What are the patterns that you need to get right? Every setup need a cleanup, symmetrical. Strict mode runs effect twice. Good cleanup makes that safe. Fetches need abort controller to avoid race conditions. Empty dependencies result to stale closures. Use functional updaters. What are some anti-patterns? Things you shouldn't do. So make sure to not do this. Object function dependencies equals to effect run every render. Don't react to events with effects. Put logic in handlers. For data fetching, prefer server components, use or stack query. Again, this is just one of the lessons in our mastery series. Be sure to check out our course in the description below so that you can build real-world projects and practice what you've learned here. Okay, thank you for watching, but here's the hard truth. Mastery doesn't come from just watching tutorials. They come from practice. That's why our courses focus on building real-world projects with the skills we learn here. So at the lowest price, you can enroll today and check them out. Thank you.